What's up, this is Christian. In this video we're going to be solving this problem. Merge two sorted lists. So what we're going to be working with is linked lists. To be honest, it's one of my greatest weaknesses. I did struggle a little bit, but I did come to a conclusion and solve the problem. So here's an example of what we're going to be working with. We're going to get two sorted lists. The head is going to be pointing at the least value, and then it's gradually going to point to the greatest value. So we have to take those two lists and then put them in the same order, in incrementing order. So we have to keep track of the head of the list, and then we have to combine the two lists so that they meet the requirements. So here's an example. We have two ones at the top over here, so we have to check to make sure that we're choosing one of these in the case that they're equal. Doesn't matter which one. And to make sure that we just choose 2 next, and then the 3, and then either 4, doesn't matter. And then that we return the reference to the head. So in this case, they chose the second list as the head. We can choose the first list as the head. It just depends on our implementation. In this problem, I show you two different solutions. I used iteration, so I use a loop to go through the linked list, and then I also use recursion. The recursion looks a lot simpler, but it's a little bit harder to decompose. Let me know if you have any confusion about the recursion. I can make a video tracing that problem, but I hope you enjoy. Let me know if you have questions. So first I'm going to solve it by using iteration, and then I'll solve it, hopefully if I don't struggle with either of these too much, I'll solve it using iteration, and then I'll solve it using recursion. So to solve it using iteration, one second. Alright, so first thing we want to do is to make sure that we'll create a temporary variable. So we'll call it temp head is equal to a temporary variable, which is equal to a list node. The value we set to this list node doesn't really matter, because at the end we're going to return temp head.next. So it's just going to refer to the next node, because that's where our actual list is going to start. So then we'll make a while loop. It's going to be while L1 is not none and L2 is not none. Okay, so that's what we're going to work with, because once one of these is none, the rest of the list is just going to consist of whatever remains from the opposing list, right? So the way we can do that is we can go temp.next is equal to, this is kind of interesting, I learned this the other day, it's L1 or L2. So it checks to see which one of these is none, and then it appends that to the end of, or the pointer to next points to that, and then that'll consist of the rest of the list, right? So now within the while loop is where we kind of need to do our stuff. So as long as L1 and L2 is not none, we're going to be in this loop, so it's safe to check the value. So if L1.val is less than L2.val, and that means that the temp.next is equal to L1. The reason for that being is we're trying to sort these two linked lists. So they're already sorted for us. So see, 1, 2, 4, 1, 3, 4, right? So we want to use whatever value is the least. So in this case, we're seeing that val is less. But in some cases, they can be equal. So that's why we can write an else statement that just sets temp.next equal to L2, right? And then I can't forget to iterate through this list. So we want to set that to that. And then in this case, we want to make sure we go to the next value of L2, and then temp equals to temp.next, right? So that should be good. Yeah, I think this should be fine. So let's try running it. I usually struggle with these. Something always comes up. I would be pretty surprised if this ends up working out. Oops. See what I mean? I forgot to put that L2 is equal to that. So yeah, that's to be expected, because we're not actually iterating through L2, so it'll like continuously try to add the same value of L2 like infinitely. So we'll add some more of the test cases. Yeah, we see we have some empty arrays, so luckily we took that in consideration, so that works. Cool. So that was a really simple solution, and this is, I think doing this, some people call this like dummy, I believe. They call this a dummy, so if this confuses you at all, there's definitely a lot of videos out there that that explain dummy nodes to you. Okay, so this will be a second implementation. Using recursion, you actually don't have to use a dummy head. We can use one of either L1's head, the reference to L1, or the reference to L2 to iterate this whole list, because since we're doing it recursively, we're still keeping track of that initial L1 that points to the head of the list. So it shouldn't be too bad. Okay. Alright, so let's get this started. So we'll start off right away to checking to see if L1 or L2 is empty, right? If L1, if not L1, or we can put similar to our last one, L1 is not none, or L2 is, well, we're checking to see if it is none actually. Is none, or L2 is none. So if this is the case, we're going to return L1 or L2. As I explained in the last one, this just checks to see which one of these is not none. So in the case that L2 is not none, then it just returns L2, right? So in the case that they're both none, it just returns none. So this is a pretty safe implementation. It's like very, very simple to understand. So now that we've checked this, we check to see if L1.value is less than L2.val, then we'll make a recursive call to L1, right? So the head of our list is going to be L1. So then we're going to make a recursive call to this method. So self.merge to lists, and then we do L1.next, and then L2. So then, since it's recursive now, we need an else statement. That'll be for if L1 is greater than or equal to L2, correct? So it'll be this same thing right here, but the next will be on the L2, right? Since L2 will be the head. And then we'll return L2, and I think that should be it. Yeah, this is a lot simpler than the last implementation. So let's run this. So we're getting an incorrect answer. Let's see. Output is 134. Okay. Okay. So we're missing, yeah, so this isn't adding anything from L1. So let's see. Since we're recursively doing this, let's see, let me think. How would we reference this, or how would we get this? Okay, yeah. So we're calling this, but we're not appending this to anything. So what I would need to do is something like this. Yeah. So L2.next equals that, L1.next equals to that. Yeah, so that way we're actually appending to the list that we're creating. And since we initialized at the beginning which list we're using, then it appends it correctly. That should work. L1.next, and at the end we return that. Yeah, so it's working. So yeah, perfect. Cool. That's actually a really, really simple solution. I got a little bit worried there for a second. Okay, so we'll submit, and this should actually work. This is a lot simpler, but sometimes recursion can be pretty confusing. Honestly, thinking about this is kind of like, thinking about recursion is a little bit difficult. The best way to understand any type of recursive problem is to trace it, trace it, make little, like, for each method call that you do, make like a block, and then as you exit, just exit out, and then keep track of the list that way. That's the best way to understand this type of code. Alright, so that actually turned out pretty well. I'm actually pretty happy with that. Let me know if you have any questions. See you on the next one.